Hey guys, the view from here is amazing! Don't you just love taking a ride on this? But I bet you don't know who invented the Ferris wheel. The answer is in the name.
Hello guys, so this is the inventor of the Ferris wheel. It is George W. Ferris. It is invented in 1893 and at first it is sketched on a cocktail napkin. For now, at 550 feet high, the tallest observation wheel in the world is the High Roller. It was officially recorded in the Guinness Book of World Records in 2014 with the record based on the diameter of the wheel, 520 feet. Hello guys, this is Mathematics class with me, Ma'am Ruth. In this Ferris wheel, can you mention your position compared to the center point of the wheel? So this is what we will learn, the trigonometric function part 2. The content is about how we use the unit circle to find out the trigonometric ratio of general angles. Our position in the Ferris wheel can be illustrated using a circle. Suppose the radius is 1. To make it simpler, in a Cartesian coordinate. As we on the wheel, we are moving around the circle with changes of distance and height compared to the center point. Depending on an angle we make, here we relate it to the x-positive axis. So, you can see this point P, inscribe the circle, and we have the angle theta, which showing you our position when we are in the Ferris wheel. So, we can mention that the coordinate of P is x, y. You can see that the base of the triangle is x and the height of the triangle is y. With the radius of 1, we can connect the cos theta, which will be x over r, since r equals 1, so that we can have x equal cos theta. Sin theta equals y over r, the opposite over the hypotenuse. Since r equals 1, then we can have y equals sin theta, and x, y can be substituted become cos theta, sin theta. If x, y, x and y is in alphabetical order, C for cos and S for sin also alphabetical. Next, if we lies on this position, so this point P is with the coordinate of 1, 0. So, if we want to connect it with the previous coordinate with theta, it will be cos theta, sin theta. So we can relate it that cos theta here is 0 degree because we will start the angle from the x-positive axis, so that we have cos 0 equals 1 and sin 0 equals 0. So this is the connection between the point and the angle. So now, if we rotate this position in here, we have the coordinate of the point which is 0, 1. And the angle we can count here from the x-positive axis, it will be 90 degree. So if we compare with the axis with the coordinate of theta, we can have cos theta, which is 90, which is equal 0, and sin 90 equals 1. So that here is the relation between 0, 1 and cos 90 and sin 90. Now we rotate it 180 degree and we can read it here that the point will be minus 1, 0, right? So with the same step, we can have the coordinate in theta will be cos 180 degree and sin 180 degree. The same for the point 0, minus 1. Here we can have the angle is 270 degree, so that cos 270 degree equals 0 and sin 270 degree is minus 1. Last, we will try to rotate it in one cycle so that we have the point is 1, 0. Then we can compare the coordinate with cos 360 and sin 360. With this condition, we also can make the cycle for 2 cycles, for example, and have the angle theta 720 degree and more than 2 cycles, for example, above 720 degree. So for now, we will try any position with the angle which is 30 degree. Here at this position, since we have cos 30 is a half square root of 3 and sin 30 is a half, so that we can match it with half square root of 3 and a half. If we move the position reflected at the left side of the y-axis, we can have the angle 30 degree with the position of the coordinate become minus a half square root of 3 and a half. And we can count that the angle will be 180 minus 30, so it is 150 degree. We can now conclude that cos 150 will be minus a half square root of 3 and sin 150 will be equals a half. If we move it at this position of quadrant, then we can have the 30 degree in the position of alternate angle. So we can count that the angle here is 180 plus 30, which is 210, and the position of the point is both negative. So that we can conclude that cos 210 is minus a half square root of 3 and sin 210 equals minus a half, right? Now we will check for the fourth quadrant here at the right side below x-axis. The point is a half square root of 3 and minus a half. You can count it here that the angle is from 360 minus 30, correct? So I have 330 and I can match that cos 330 will be a half square root of 3, sin 330 is minus a half, and if we need the value of tangent, the tangent always be the ratio between sine over cos. In this case, we have tangent 30 will be 1 over square root of 3 or 1 over 3 square root of 3 in the negative sign. Then we can conclude all of that position of the angle in this all quadrant. So also we will decide the sign of the trigonometric ratio in this 4 quadrant. The first quadrant will be for 0 degree up to 90 degree. The second quadrant is between 90 degree and 180 degree. Between 180 and 270 we have quadrant 3, and between 270 and 360 we have quadrant 4. Since we have the relation between x, y and theta, x is cos theta, y is sin theta, then we already see that for any angle in the first quadrant, since x value is positive and y value is positive as well, then here all ratio will be positive, sin theta, cos theta, and tangent theta. What about in quadrant 2? What is S4 here? S for sine. Since at the quadrant 2 only sine that is positive, you can see at the value that sine is related with the y value. At the quadrant 3, tangent will be the one that is positive. Since x value and y value both negative, then the ratio of tangent will be positive. At the quadrant 4, since the y value is negative, then we can have the ratio of cos will be positive. Later, we also will relate all of the angle with the alpha, which is called the basic angle, in quadrant 1. If we move alpha at the second quadrant, so you will have the relation of 180 minus alpha. At the third quadrant, you will have the relation of 180 plus alpha. And at the fourth quadrant, you will have the relation of 360 minus alpha, which will have the same value with alpha with the sign related to the quadrant. So for now on, that's all. We will continue it later. Thank you for watching the video until the end. Please stay safe everyone, and God bless you all. Bye bye.